Metaprogramming is the writing of computer programs with the ability to treat programs as their data. It means that a program could be designed to read, generate, analyze and/or transform other programs, and even modify itself while running. In some cases, this allows programmers to minimize the number of lines of code to express a solution, or it gives programs greater flexibility to efficiently handle new situations without recompilation. The language in which the metaprogram is written is called the metalanguage. The language of the programs that are manipulated is called the object language. The ability of a programming language to be its own metalanguage is called reflection or reflexivity. Reflection is a valuable language feature to facilitate metaprogramming. Having the programming language itself as a first-class data type is also very useful. This is known as homogeneity. Generic programming invokes a metaprogramming facility within a language, in those languages supporting it. Metaprogramming usually works in one of three ways. The first way is to expose the internals of the runtime engine to the programming code through application programming interfaces. The second approach is dynamic execution of expressions that contain programming commands, often composed from strings, but can also be from other methods using arguments and/or context. Thus, programs can write programs. Although both approaches can be used in the same language, most languages tend to lean toward one or the other. The third way is to step outside the language entirely. General-purpose program transformation systems, which accept language descriptions and can carry out arbitrary transformations on those languages, are direct implementations of general metaprogramming. This allows metaprogramming to be applied to virtually any target language without regard to whether that target language has any metaprogramming abilities of its own. Approaches: in statically typed functional languages, usage of dependent types allows proving that generated code is never invalid. Template metaprogramming. CX macros, C++ templates, staged metaprogramming, MetaML, MetaOCaml, macro systems, scheme hygienic macros, macrum, template Haskell, IBM/360 assembler. The IBM/360 and derivatives had powerful assembler macro facilities that were often used to generate complete programs or sections of programs. Macros provided with CICS transaction processing system had assembler macros that generated COBOL statements as a pre-processing step. Examples: a simple example of a metaprogram is this POSIX shell script, which is an example of generative programming. This script generates a new 993-line program that prints out the numbers 1-992. This is only an illustration of how to use code to write more code. It is not the most efficient way to print out a list of numbers. Nonetheless, a programmer can write and execute this metaprogram in less than a minute, and will have generated exactly 1,000 lines of code in that amount of time. A quine is a special kind of metaprogram that produces its own source code as its output. Not all metaprogramming involves generative programming. If programs are modifiable at runtime or if incremental compilation is available, then techniques can be used to perform metaprogramming without actually generating source code. Lisp is probably the quintessential language with metaprogramming facilities, both because of its historical precedence and because of the simplicity and power of its metaprogramming. In Lisp metaprogramming, the unquote operator introduces code that is evaluated at program definition time rather than at runtime. See self-evaluating forms and quoting in Lisp. The metaprogramming language is thus identical to the host programming language, and existing Lisp routines can be directly reused for metaprogramming, if desired. This approach has been implemented in other languages by incorporating an interpreter in the program, which works directly with the programmer unregistered trademark S data. There are implementations of this kind for some common high-level languages, such as REM objects, a unregistered trademark Pascal script for Object Pascal. One style of metaprogramming is to employ domain-specific programming languages. A fairly common example of using DSLs involves generative metaprogramming. Lex and Yak, two tools used to generate lexical analyzers and parsers, let the user describe the language using regular expressions and context-free grammars, and embed the complex algorithms required to efficiently parse their language. Implementations. See also the list of program transformation systems. See also Notes. External links, c2.com wiki, Metaprogramming article, Metaprogramming on the Program Transformation Wiki, Code Generation versus Metaprogramming, Solenoid the first metaprogramming framework for ExistDB, The Art of Enterprise Metaprogramming.